For example 3, you have to multiply what's on the outside first. So 7 times 3 would be 21. Then on the inside we have 5 times 20, which is 100. And then this x to the first times x to the fifth means that you add x's. So that would be x to the sixth. Alright, so now 100 is a perfect square. And so instead of having the 10 inside of the square root, that 10 comes out of the square root symbol. So square root of 100 is 10. If I had 6 x's, I have 3 pairs. So x to the third would come out on the outside of the radical. And since there's nothing left over, there's nothing that goes inside the radical. So 21 times 10 is 210. And then we would just have x to the third. For part B, again, we're going to multiply the outsides first. So 2 times 3 is 6. On the inside, we have 7 times 14. And 7 times 14, I can't find my calculator. Let's see, 7 times 14 is 98. And a to the first and a squared makes a to the third. Because if you multiply the same base, you add the exponents. Alright, so for 98, that is not a perfect square, so we need to break that down. So I know to get 98, I multiplied 7 and 14, so I'm just going to use 7 and 14. And 14 can break down to 2 and 7. So I have a 2, a 7, and 3 a's. So I have a pair of 7s and a pair of a's. So now, that 6 still stays on the outside. I put the 7a on the outside, and left over is a 2a. So 6 times 7 is 42a, and then the 2a stays inside. Example 4. These are just fraction problems, but these are kind of nice, this first part here for A, or example 4, A through D, because they're all perfect squares. But you want to reduce if you can. So 64, the square root of 64 is 8, and the square root of 49 is 7. Well, 8 sevenths can't reduce, so I'm just going to leave it. Okay, here the square root of 25 is 5, and the square root of 100 is 10. But 5 tenths can reduce to 1/2. Okay. The square root of 36 is 6, and the square root of 4 is 2. But 6 divided by 2 can make 3. And then the square root of 81 is 9, and the square root of 121 is 11, and that cannot reduce, so I would just leave it 9/11. In example 5, we see that only one of the numbers is a perfect square, which is 16. And so I'm going to go ahead and set it up. So the square root of 16 is 4. But I have to do some work to get the top number. So 12 I have to break down in a factor tree. So that would be 3 and 4. And that becomes 2 and 2. So we have 2, 2, 3 with a pair of 2's. So the 2 on the outside and 3 on the inside. And once again, like if you can reduce, you should reduce. So I see that the 2 and the 4 are on the outside of the radical. So I could reduce those because they're even numbers. So 2 goes into itself 1 time, and 2 goes into 4 2 times. So this would look like 1 radical 3 over 2. But when you rewrite this, this 1 is really unnecessary. You don't need it if it's in front of the radical. So my final answer is the square root of 3 over 2. Okay, so part B. Let's set it up. The square root of 64 is 8. And let's break down this 8 with a factor. If we break down 8, now this 8 is coming from the top one. not this. So this breaks down to 2 and 4, and 2 and 2. So I have one pair of 2s, goes on the outside, the leftover 2 on the inside. Now I can only reduce if something's on the outside together or on the inside together. So this 2 and this 8 can be reduced. I can't touch this 2. So I know 2 can go into 2 one time, and 2 can go into 8 4 times. So this would look like 1 square root 2 over 4. But again, we don't really need that 1 out front. And even though it looks like we could be able to reduce the 2 and the 4, we can't because that 2 is inside of the radical. Okay. For letter C, let's set up for our answer. The square root of 121 is 11, but the square root of 48, we need to break it down. So let's go with 6 and 8. And break down again to 2 and 3. 2 and 4, but 4 can break down to 2 and 2. So I have 4 2s and a 3. So this gives me 2 pairs of 2s, so I take a 2 times a 2, and that's a 4. The leftover 3 goes on the inside. Nothing on the outside can reduce. So my solution is 4 radical 3 over 11. And then lastly here, we have the square root of 144, which is 12. 60, we need to break down. I'm going to go with 6 and 10. 6 becomes 2 and 3, and 10 becomes 2 and 5. So I have a pair of 2s, and multiply my leftovers. 3 times 5 is 15. Now, for the 2 and the 12, those are both even numbers that I can reduce by 2. So 2 divided by 2 is 1, 12 divided by 2 is 6. So I have 1 square root 15 over 6, but again, we don't need that 1, so the square root of 15 over 6 is my final solution.